math lovers everywhere.
And those of you who just don't care.
I'm Jordan.
And I'm Blake.
And welcome to Mathcraft.
Today we are going to show how to divide rational expressions.
In a minorly more entertaining fashion compared to writing. Why don't you start, Blake?
Let's go. Now to start a problem. The first thing you want to do is set up your problem so that you can do it. Because the problem is a division problem, you want to flip the second fraction and multiply. Next, you want to factor all parts of the rational expression. So the original problem turns into n minus 4 times n minus 5 over 6m to the 7th n to the squared times nmn squared over 5 times n minus 5. Now you may be wondering, how in the world did those parts of the fraction turn into what they did? Well, when factoring, the top part of the first fraction is a trinomial, and you factor using your trinomial factoring trick. To do this, you want to make a big X. On the top of the X, you want to put the number before the variable in the middle of the problem. It will be a negative 9 in this case. Then you want to take the last number of the trinomial and put it on the bottom. It would be a 20 in this problem. Now you want to find two numbers that add to the top number and multiply to get the bottom. For this problem, it'll be a negative 4 and a negative 5. For the second fraction, the bottom part has a GCF of 5. So 5n minus 2 turns into 5 times n minus 5. You can cancel both of the n minus 5s, and you can reduce to the 10 and the 6 using 2 as your least common multiple. You have 5 and a 3. Now, a part not shown is multiplying the 5 from the bottom part of the second fraction and the 3 from what I just showed. So in the end, your problem should be n minus 4 times 5, or switched around, over 15m to the 6th. Now you can cancel, you can reduce again, the 5 and the 15, so that will get rid of the 5, and make the 15 a 3, and your final answer will be n minus 4 over 3m to the 6th. Now let's do a harder problem. Like the last problem, the first thing you want to do is set up your problem so that you can do it. So this means flipping the second fraction and turning it to multiplication. As you see, I have already done this. Also, like the last problem, you want to factor all parts of the rational expression. The bottom part of the first fraction is a trinomial, so you can use your trinomial factoring trick to get n plus 7 times n minus 5. The top part of the second fraction has a GCF of m. So you take that out and you get m times m plus 7. Next, you can cancel the m plus 7, which leaves you with 17m to the third over m minus 5 times m over 34 m to the 8th n to the 4th. You can also reduce the 17m n to the third and the 34 m to the 8th n to the 4th to get 2m to 7th n on the bottom part of the fraction. So all in all, when that's all done, you get m over m minus 5 times 2m to the 7th n. Then the m's can cancel to give you 1 n over m to the 6th times m minus 5. And you are done with your problem, and you can cheer because you don't have to do math anymore. Hallelujah.
And now on to my problems. First, I'll start with an average one, which is 12m squared over m minus 5 divided by 3m to the third n over m squared minus 25. For the purpose of the problem, I've already flipped the second fraction and converted the problem to multiplication. From here, the parts of the fractions are factored, using the difference of two squares method in this case, splitting m minus 25 to m minus 5 if times m plus 5. Both of the m plus 5s then cancel, resulting in 12m squared times m minus 5 over 3m squared n. The 12m squared and 3m squared n then reduce, leaving 4 times m minus 5 over n as the final answer. For the second problem, I'll be using 12n minus 36 over 9 minus n squared divided by 8n to the fifth over n squared plus 3n. As with the first, it is flipped and then factored with difference of two squares, as before, but also by taking a GCF from n squared plus 3n. This then leaves 12 times n minus 3 over 3 minus n times 3 plus n times n minus 3 over 8n to the fifth. For now, only the n plus 3 and 3 plus n can cancel, because addition is universal. But by taking out a negative 1 from 3 minus n on the bottom, it and the n minus 3 cancel also. We now have 12n over negative 8n to the fifth, which reduces to negative 3n to the negative fourth over 2. Finally, the exponent is flipped, because negative exponents are not allowed, which brings the final answer to negative 3 over 2n to the fourth. Thanks for watching!
We hope you enjoyed it.
How about we end this with a bang, Blake?
Why not?
All you, dude.
Gladly.